So, so those of you that don't know me, just will do a quick introduction, and then I'll get right into the agenda. So, my name is Max Aulakh. I'm one of the managing directors here at Ignite. I'm a prior Air Force guy. I've got a lot of commercial experience, primarily healthcare and financial services. And I also like to consider myself an old school ATO guy. So a lot of DITS cap, die cap, and RMF work. I've seen a lot of variations of RMF, and I'm here presenting to you as an ISSM because we're very excited about this OSCAL thing. So that's just a little bit about myself. Our company is helping on a CRADA, cooperative R&D effort for OSCAL. So please connect with me on LinkedIn and things like that. So here's kind of our agenda for today. We'll talk about components, the main reason why we need components inside of OSCAL, how are we building out the components, things like that. But it's really important to understand some of the challenges that we're facing in the DoD, and then also some of the modern factory challenges. So we'll kind of set the context of how we look at a component, and then after that, I'll show you the process so that we use to aggregate data from a component. We'll look at some component analytics, is what we call them. What does it look like when you do aggregate all of this compliance data together from an ISSM perspective? And definitely a demonstration, and then briefly talk about the future initiatives. So we've got about 45 minutes. You'll be here with me. Please ask questions towards the end, and I'll try to get through the slides as quick as I can because the fun part is actually the demonstration and everything like that. So again, like to thank everyone that's here, and Pauline and Michaela, thank you so much for having me on here. Okay, so if you don't know what a software factory is, just Google the term. Essentially, a lot of innovation is happening across Department of Defense, and there's about 20 plus software factories that are trying to essentially speed up accreditation processes, innovation, bringing more technology, modern methods into the government. And one of the biggest challenges we have is there's a very slow approval process for an ATO, and we don't really know the scope as prior ISSMs, old school ISSMs as I call it. Are we accrediting a package which doesn't move, or are we accrediting a process? So there's a lot of discussion around that. And because of the flexibility, the methodology, how are we accrediting? How do we achieve a continuous state so that it's not just a paperwork thing that we wrote one time? It actually reflects the truth. So how do we get to this truth, maintain the truth? So these are some top challenges. Obviously, there are other challenges like inheritance, reciprocity, and then the platform boundary itself, as well as, how do I just accredit the mission app only? A lot of people talk to us about the SaaS application or the mission app. How do I just do that? And components are a key part of that sort of thinking. So before we get into kind of the components, there are a couple of different points of views that are very important for us to understand, because the way you design components, it really depends on the point of view. So FedRAMP has this main point of view. The only thing I would say about this slide is that the continuous monitoring is actually up front. So when I mentioned how do we get to a continuous state, FedRAMP does address this by putting it up front. But the challenge is that it can still take it can still take up to a year, which is really it's a terrible thing for a lot of people that are trying to accomplish this. And OSCAL and components are designed to help solve that. So it's a linear workflow here, right, where the ISSO and the ISSMs pass it on to the SCA, and then the SCA representative, the designated approval authority, and the approval authority, right? Very, very linear flow, takes a long time. So when you combine the context from the industry, the software factory, and you go into the DoD, what you're going to get hit with is just the DoD's point of view of RMF. And this process is very much nuanced, is how I like to say it. There's the DISA IL process, there's the Navy, you have different types of DoD components or DoD organizations that like to put their own spin on it, right? So understanding the point of view that you're coming from is going to be very important in order to build and aggregate these OSCAL components. So additional context for DoD, I'm presenting this as a case study because as we're going through this process, working with the DoD, we're coming across a lot of resistance, and a lot of this has to do with language confusion. So one of the things that we learned about components is that you can add them all up to drive out a capability. When you present that, aggregated together, that's not the same thing as a DoD capability. There's something called a DODAP model, which you can go look at. And so it's important to understand that this is not a DoD capability. Also, this is not a DoD component. That's an organizational level thing. So whenever we're building out OSCAL components, some people have asked us, is this for a DoD component? No, those are entirely two different things. So context really, really matters in terms of, prior to building a component, and we'll get into kind of steps we had to take to do that properly. All right, so another thing that's important, this is kind of where we get a little bit more technical before we go into the software and things like that, is people ask us, well, how do you reconcile the components against the SBOM components and then the RMF? So at the bottom, the things that you see right here is from a standard called Cyclone DX, which talks about software bill of materials. And you have a lot of, I would call subcomponents of a total system, where you have applications, libraries, different containers, devices, files, and firmware, all sorts of different things. You can reconcile these components that are part of Cyclone DX against an OSCAL component, so that's a good thing. The other thing is when this software is deployed into a cloud environment, with a cloud service provider, the platform layer like the Big Bang platform, and the mission app, each layer will have its own set of components. So it's very important to understand the context of where you're building this component, because after you aggregate them, there needs to be reconciliation and reconstruction of the whole SSP depending on the target environment. And that's very important for reusability, right? So for us, it's very important to understand, the definition, right? So here, this slide, I found this little calcium thing. I don't know what that is. I typed in OSCAL. We thought it was funny. All of these major problems, OSCAL is here to fix these problems, right? So, but we love the component definition because it's purposefully broad and flexible. What this ultimately means is that it's not very opinionated. So when it comes from a development standpoint, you can define components in many different ways. It encompasses vendors, right? Everything from like a large organization to a very simple policy or a simple technical component around a software, right? So this gives us a ton of flexibility and room, which is good as developers in ISSM, but it's also very bad because when we get to the DoD with the actual organization, there's literally the first first part of this is just setting the context, just understanding what you're going to build, why you're going to build it, so it can be reusable. That's our main goal for doing a lot of the legwork. So we love the definition of it, how it works, but just remember where you are, in what context, if you're on the private side, if you're on the public sector side, how you define components is very different, and some of these components obviously can be sensitive depending on the environment, right? So here, now we'll get into kind of the aggregation techniques, and again, first we want to talk about why do we do aggregation and what is aggregation. So essentially, why do we want to do aggregation is when you have a ton of components that are tied to a control. The theory is that in the future, in potential, you can just combine all these components together to deliver a starting point for an SSP. So as an ISSM, I'm always looking for starting point of an SSP because I don't really have the knowledge of moving software at all the time, right? I'm disadvantaged from that perspective. From a software engineering perspective, they're disadvantaged from the control selection, the tailoring on all of that stuff. So as much definition that they can provide me, it gives me a good running start, right? And so the other goal is this. If we build the components the right way, as you can see this graphic, right? Big Bang container, right? Mission app module, right? You can build these in such a way that allows you to redeploy that component without really knowing what the target environment is going to be. This is very important for us if we're working, let's say, in a classified space. We're building components on the outside, but then the mission and the environment that it gets deployed to is completely unknown, right? So this could be a cloud environment, on-prem environment. And really it really comes down to reusability from a development standpoint, but also it just saves time and money, right? So that's very important. That's the reason why we do this. And here's kind of our process to aggregate these components. And this is where I'll kind of get into the demonstration of the software and things like that. So this is a loose process. That's why you see these little bubbles that are just kind of it's loosely defined. So first is building the component itself. We're looking for really hammering out the definition, the scope of this, when will it be used, and then the controls and the type. Obviously, some of these things are provided in this component definition, but we've kind of expanded it to fit our needs within the DoD. The second thing I'm looking for is the collection process of how many components will go inside of a single SSP, right? And that forms my boundary. And the type of components, are they a technical component, a boundary component, or written for a set of controls? That's very important. The other thing we're running is basic analytics on a component. Aggregation analytics is what we call it, is where we're looking at the interconnections between components through this, through a URI or any other data that's available to us. That's very important, and we run basic aggregation analytics, which I'll show you what that kind of looks like for us, for some basic decision support in terms of prior to building an SSP. A big SSP sometimes is not a good thing for us as the ISSMs. And then the last, or then the next step is aggregation. So once we've built it, collected the aggregation, we're looking at kind of two things. We're looking at obviously the control ID, which is good. NIST provides us that, but we also have our own control ID because people like to change control IDs all the time. So we have a hidden control ID, and then also we're doing language harmonization techniques. So Ignite, half of Ignite is actually a language shop. I used to be a linguist myself, so we do a lot of language harmonization because you can modify the language of a control if you wanted to as well. So we've seen those types of RMF cases, especially in higher education, right? Compared to DoD, you get standard language and things like that. So language harmonization and looking at the parameters, things like that is very important. And then the expectation is that if you do this the right way, you're aggregating the components properly. Me as the ISSM, I should get two things. My rough boundary diagram with just basic components. We haven't done this yet, but that's what I should get. I should understand all the components that are part of my boundary. And then I should get initial aggregated language that's been harmonized with some level of coherence on their sentences. That's very important for me. That is what's going to reduce my work as the ISSM and that's going to help me generate a faster SSP, faster approval, things like that. So that's kind of the process we go through, and the build and the collect were kind of the build is the first context of first part of the slides, right? If we're working with a software factory, our build process is different than if we're working with like an on-prem technology or platform IT, weapon systems, those kinds of things. It's very the context sets kind of our cadence. So the next thing we'll do, and I'm going to try to do this, I'm going to try to switch here, is essentially show you what this demonstration looks like in terms of our software. So give me 1 second. I'm going to see if I can switch and restart my sharing. Okay. All right. So I believe you can see my screen now. Okay. So I am going to. All right. So I've got different environments open, which is awesome. So different environments for different things. So one of the first things in our software, we deploy different types of capabilities depending on what we're trying to accomplish. But here we set up the environment for just kind of monitoring the build process of a component, authoring components, authoring a final SSP, things like that. So one of the first things we do is we set up a component pipeline that matches our process. Building components, collecting, aggregating, me as the ISSM receiving my initial SSP, and then as I mentioned, it's loose, right? So we're still defining further process, but essentially I need a final SSP, I need a SCAR review, which we'll get to at another workshop sometime, and then finally I need to get to the AO, right? So I've set up a basic pipeline, and within this pipeline, different things happen by different types of folks, and we also use a lot of different types of frameworks because we can actually build. There's a mapping component to building components based on any type of regulation and standard out there. So one of the things that we do in these stages is the first thing is just understanding the workload. We'll get to kind of the container analytics here in a minute, but essentially the goal is to get to kind of the aggregated state. So after the initial build, we can push things, as this pipeline is linked, we can actually push things into the aggregated state, and it gives us kind of a preliminary understanding of if there's a missing URI, missing port, if it needs a POAM at a component level, it kind of provides us that information. Then after that, when we are talking about building the initial SSP, we can actually start to push a lot of that information from each and every component into the control. This includes the aggregated responses, and if there's additional data like test case language for us to consider, we just build that out on additional tabs and things like that, right? Again, my goal has always been I want to do least amount of work writing as possible. So somehow we need to take data from existing components and coherently build a sentence where we can actually start to have sample language to start with, right? And all of this can generate a future SSP, right? So again, this is the initial SSP. This is where you would kind of dive in after we've kind of built out our initial components. The next thing is really looking at component analytics. That kind of happens in this collection phase. So I've got like 4 or 5 analytics or 4 or 5 components here. Back to my original slides. One of the things that we talked about in the slides, which I'm gonna switch because this is the Google version of the slides. But one of the things we talked about on the slides was, I need to understand the amount, how many components are there, the type, the size, the interconnections, things like that. This requires an analytical capability coming from the component itself. So I've got different things that are open for that. So we do a lot of visualizations because obviously we can present all this data inside of spreadsheets. But for us, any chance we get to do SCTM, controls overlay examination or component examination. We try to do that visually. So the outside here are the control families. The inside, sometimes we try to display things like the size of the actual component in terms of how many controls there are. The types can be color coded by the color. And then in terms of just workload understanding, the bigger the component, we can actually set different kinds of trigger that helps us understand the bigger the bubble, more work effort there is, right? So basic analytics, we're able to project from actually all of the collected components to kind of build out in a component analytics view as well. The other thing is, we do a lot of work in terms of just understanding dependencies, because once you have lots of components with lots of controls individually addressed inside of each component, you're going to have a lot of interdependencies of controls. And so for an ISSM, all of this work happens in massive amount of spreadsheets and 900-page SSP documents, not very clear for the AO and not very clear from people who are making the decisions, and therefore the decision is elongated, slows down the ATO. So for us, we do a lot of work in terms of just understanding how each control from one component connects to another. We can project things like, hey, this component is providing us a compliant control, but another interrelated component is providing a non-compliant control. And we can do simple highlights of, this control primarily has all the green. Green means it's primarily compliant, and then red kind of shows you the sources of the controls and interrelated components where it might be non-compliant. So having kind of the analytics capability behind the aggregation has really helped us for showing the component dependency. And you can pull this right out of the URI, by the way, which is a defined field inside of your component library. So the other thing is, so this is the basic demonstration we like to show. We do have, you can check out our release notes on our website. I think we're on Ezra right now. But every time we push out a new release, we place it out there. But more importantly, we're pushing out 2 releases a month, right? So each time we're solving the problem together with kind of the government and under the CRADA. We try to put that in some sort of a requirement and push it out there as much as we can. And reason why I say much as we can is because some of the work is actually protected. Some of it we're not able to actually release it, even though we would like to because of the sensitivity of the work. So what I'd like to kind of close this off with is just to kind of recap what this process looks like, right? So first, we need to build, and if you're building components, always take into consideration, take more time on the definition, understanding the scope, where that component is going to land. Because if you're writing components, your main job is to make it reusable. If you don't pay attention to the scope of that particular component, it's going to be very difficult for it to be reusable. We've already written components that are basically one-time use, and we're trashing them, meaning we're rewriting them all over. That was part of our learning. And then after that, in order to build an SSP, we are collecting all of the components and examining them by size and how many components need to be inside of a target SSP or a target environment. And then after that, we are looking at interconnections of the components. Then after that, we are automating more and more in terms of language, sample language, language harmonization, looking at getting better at language, natural language generation. This is a pretty hard thing to do, but we're just starting to get better at it. So it's not perfect. We still need a human in the loop, and that's been kind of its own R&D product. And then the last step is just as an ISSM, I want to be able to have my initial set of boundary diagram, if at all possible, and then I want initial set of language. If you can do that, for your ISSMs, it doesn't matter where you're coming from, you've just probably saved them like 6 to 9 months of work, right? And as this cycle gets better for us, meaning we're getting better at building, collecting, and harmonizing language, that cycle can be shrunk even shorter. And that's really the ask from a lot of the factories, a lot of the DoD places that we go to, and a lot of the ISSMs that we serve. They genuinely want to speed up the process, but they don't know how to, right? And so a lot of developers are volunteering and helping, but having this contextual understanding is going to help you generate a good component, right? So we might end a little bit early for some questions and whatnot. And how did you? So I'll answer some of the questions towards the end, and then we'll go from there. So. Future initiatives, what we're planning to do next. This is what our goal is, and we'd love to collaborate with other teams that are trying to do this. So I'm an old school FedRAMP person, where I've been doing all of this stuff myself and with my team on a lot of paper, Excel sheets and things like that. So our first objective is to figure out how to optimize the whole FedRAMP process, and we think components are really the way to go. And then a lot of small businesses are coming to us and asking us, hey, FedRAMP is expensive, so how do we build, I call them assurance cases, where you have pre-built evidence. There's actually a NIST guidance around assurance cases, which is pretty awesome. So we're looking at building small business assurance cases, which is fantastic. The second pillar is we want to expand the work on our existing cooperative R&D agreement with the 16th Cyber Command. So if you're interested in partnering from that perspective, that will be awesome. But there are kind of tight requirements around what can be released in open source and what cannot be released, data rights and those kinds of issues. But if you're already working within this space and you want to get a little bit more context of what the government is looking for on how to make this ATO process faster, please get a hold of us, because that's really majority of the work is going there in terms of our research and whatnot. The other thing I want to call out is Iron Bank. If you don't know what that is, please research it, but essentially it's all the containers that have been approved, right? So there's so many different containers that are already approved. Each container ideally should have a OSCAL component. And so we're looking to build out Iron Bank's OSCAL components over time with this CRADA in place, and then also we're looking to do basic language generations to give me a starting SSP, which is fantastic. The other item that people always ask us, hey Max, can you guys release some of your stuff in the open source? We'd love to. We are in the middle of actually trying to release an API. We're also in the middle of trying to see if the government would allow us to release some of the work that we have written into, somehow they have said some of this stuff falls under ITAR and things like that. So we're trying to work with them in terms of recategorizing software so it can be released. So I've got to seek permission, but there's a good amount of work that over time we should be able to release some APIs into the platform and things like that. The last thing is, if you are passionate about not just software development, but if you really like being an assurance professional and you want to collaborate on component, we will welcome you with open arms, because trying to find somebody who knows software engineering plus they love assurance, usually people hate assurance, if they like those two things together, we want to collaborate with those kinds of individuals. So I myself, I'm a baby developer, but a very big assurance person, and we have really good developers, and they have some level of assurance background. So we kind of need to mix and match both. The other thing that is coming in the near future is SCF integration. So Secure Controls Framework, if you've heard of it, it's by a gentleman named Tom Cornelius, and of course there's lots of other frameworks out there, ISO 27000, PCI, so on and so forth. Obviously, I'm a fan of NIST. We kind of have the high water mark in terms of the expectations for assurance and whatnot. But as I mentioned in my background, when we're going to financial services, when we're going to healthcare, we're running into legislations like HIPAA and PCI. So there's a nice way to integrate with those and into 853 as well. So that's some of the future initiatives that we're looking to work on, and would love to kind of collaborate. So let's come to a summary really quick, and after that, would love for you to ask any questions and answer any questions about the presentation, the demonstration. It doesn't matter, just whatever comes to your mind. Would love to kind of get some feedback on where you guys are going as well when it comes to component aggregation. So the first foremost thing we talked about is challenges. In order for us to get better, we have to reduce costs and we have to get faster. So reciprocity is a real thing. We want to figure out how to do that. And every time we write components, we have to figure out a way to reuse them, right? And then the second thing is the context. If you're working within a FedRAMP context, it's going to be very different than, let's say, the DoD context for platform IT, right? Because the way you can slice and dice components is very different. You can some people are asking for operational documentary components. Tell me how I do access control, and just talk about access control only. Don't talk about any other controls, right? And so context matters, right? So here there's a ton of language confusion when you're introducing this into the DoD and adding SBOM into it and talking about the DoD architectural framework, which has its own language based around capability. There's a lot of reconciliation of language because each one of these context means something very different when it comes to creating a component. So constructing an SSP and deconstructing it based on some of these contexts is very important. So we try to think all the way through and then try to reconstruct it based on that. And then the last thing I showed you briefly is just kind of our pipeline of component building, right? We basically talked about we build them, collect them, and then we aggregate through some analytics. And then after that, we're doing a language harmonization to really push out an initial SSP. So that kind of includes my brief yet fast talk. I went fast because I know you guys have been on this thing for about a day or two. And I'm looking forward to collaborating, learning. This is a kind of a learning thing for us. But if you have any questions and reach out to us and whatnot. So, all right. So, a couple of questions that are being asked, and here I don't know if anybody wants to jump on. You can, but you can also just message. So, somebody asked, how did you end up having to rewrite component definitions? So, for us, what we were looking to do first is really trying to figure out how much abstraction we want to provide in a component. So what I mean by that is when you look at something like a Big Bang, right, which is the platform as a service, the kind of play that's being released by the Air Force, or Space Force. So sometimes you can actually encapsulate that entire Big Bang, every single software package inside a Big Bang into a single component. That's the path we started, but other times you can actually look at each and every software package that is part of Big Bang and try to write components based on each software package. We started kind of at the high level, like, hey, I'm going to consider this whole Big Bang thing a single component. And what we found that there wasn't enough fidelity. So our AO and folks that we're working with, they're like, nope, you need to drill down a little bit more. So now we're like, all right, maybe we do our component definition at a container level because Iron Bank has all of those containers. So we went down a path, starting to write, but then we kind of reverted because of the expectation of an AO, and that required us to rewrite the scope and the definition, right? Because the type changes a lot, right? The other thing is, okay, awesome. Well, I was just answering questions, so thank you, everyone. I appreciate it. I should have done a time check, but Amber, I appreciate you asking the questions, and I thank you, NIST, for letting us present.